Hello and welcome. In this tutorial I will introduce the proportional edit tool to add some bumps and wrinkles to the top hat and make it look a bit more interesting. I will add some more sculpties to the hat. And during the ongoing course of this tutorial I will also introduce global view and local view, and I show you how you can add vertices to your object by using the loop subdivide tool. We will also see how we can temporarily hide vertices. And once we are finished with our model, we will see how we can examine the sculpt map on the fly, and how we can transfer a complex object from Blender to Sculpt like with almost no effort. Let us start with proportional edit. So what can we do with it, and where can we find it? The function can be enabled in edit mode by clicking on the circular icon at the bottom of the 3D viewer, and then selecting Connected in the upcoming selection box. Let us select a single vertex to see the tool in action. As soon as the vertex is moved or scaled, a white circle appears around the center of the selection. The mesh behaves as if it were made out of rubber, and the circle shows the influence range of the tool. You can change the range with the middle mouse roller. The bigger the radius of the circle is, the more vertices will be moved along with your selection. So this function allows us to move single vertices around, and move adjacent but unselected vertices very smoothly along with our selection. Proportional edit also applies to rotations and scaling. Until now we have used smooth fall off, which happens to be just the default setting for the proportional edit tool. Now I will enable random fall off, which will give me an easy way to introduce some random buckles to the object. I select one vertical column of vertices. Then I scale the column down a tiny bit. At the same time I roll the middle mouse wheel downwards towards me, until the mesh starts to bump up and down randomly. I turn the wheel slowly until I find a pleasing shape. Now I click on the left mouse button, and as a result we eventually get a bumpy top hat. Let us do one more tweak, and switch the tool to linear fall off. I select the top edge loop, and scale it up a bit. You might need to reduce the influence range now, by rolling the middle mouse button upwards, until you can see the white circle again. Adjust the influence range to your needs, but be warned. It may take some experimentation time until you can work with it fluidly. Remember that you always can press the escape key to revert your last change. Now turn off proportional edit. And also take a look at the top pole. The pole vertices have unintentionally been separated while we randomize the hat. Let us correct this by selecting the pole vertices and scale them down to 0. Maybe we also need to move the vertices up or down a bit to avoid a large bump on the top. And at the end we get sort of a western top hat. It now looks like it is owned by Dr. Dolittle. Now let us add a sculpted bow, and let us start with a torus shape. Go to Object Mode. Then press the space bar to open the Mesh menu, and navigate to Add Mesh, Sculpt Mesh. Change the Shape Selector to Torus X, and set the torus radius to 0.1. Then build it. Well, the new object is partially hidden by the hat, so let us move it along X until it is in front of the hat, and then go on with modeling. But we also can hide the hat for a moment. Blender has got something for you here. Go to View, and there you see that currently Global View is selected. In Global View, all objects of the current scene are displayed. As soon as we change to Local View, Blender will hide all unselected objects. Hence, since it is currently the only selected object, we only see the torus now. Of course, all hidden objects unhide again as soon as we switch back to Global View. If you have a number path, then you also can use the division key to toggle between the views. Now, while keeping in Local View, go to Edit Mode and select Side View. Ensure that all vertices are selected and flatten the object along the Z-axis by a factor of 0.25. You can do this by first pressing the S key, then enter Z, and finally enter the value 0.25 directly from the keyboard. Proceed in the same way for all following subsequent modifications. Now scale the object up along the X-axis by a factor of 4. Go back to Side View, select only the middle vertices at the top, and move them down to the object center. Do the same with the middle vertices at the bottom. This time move the vertices up towards the center. Now go to Top View, grab all of the middle vertices, and scale them down along the X-axis by a factor of 0.3. Go back to Object Mode, and add another torus. This time set the radius to 0.2 and build it. Rotate the object along Z by 90 degrees. Scale the object down by a factor of 0.25. Then scale it up along the Y-axis by 4. Also scale it up along the X-axis by 1.3. And finally scale it down along the Z-axis by 0.5. Now examine what we got so far. We face a problem here. We see an undesired intersection of the objects. So let us try to correct this now. To solve this issue, it would be nice to get some more vertices near the intersection. And again, Blender has got a helper tool for us, named Loop Subdivide. But hold on. We have to keep in mind that sculpted prims have a fixed face count. We cannot simply add vertices, because this would violate the rules. On the other hand, we are currently not working with the sculpt mesh but with the control mesh. The final sculpt mesh will be created during bake time. And the good news is that the primstar baker tool will take care about the correct transformation from the mesh to the final sculpt map, so that the second life constraints are fulfilled at the end. But this does not mean that you can add or remove arbitrary vertices in your model. However, the Loop Subdivide tool is sculpty friendly and we can use it without getting into trouble. We also can use the image editor to directly monitor the changes in the sculpt map. Select the bow and go to Edit Mode. Go to the UV Image Editor and enable the button Sync UV and Mesh Selection. This makes it easy to see what happens. Now we will see the Loop Subdivide tool in action. Go to Mesh, Edges, Loop Subdivide. Or use a shortcut by pressing the Control key, followed by the R key. Every time when you position the mouse near to an edge, Blender will calculate a new loop, which passes through this edge, and cuts it into 2 pieces. Move along your object until you find a convenient loop. Then click the left mouse button. Now the new loop will be created. And again, by moving the mouse, you can move the loop around until it is located exactly where you want to place it. Then left-click, and your new loop is added to the mesh. Deselect all vertices, and watch what happened to your sculpt map. The new loop is seen in the sculpt map as additional row of vertices. You immediately see that we have increased the vertex density where we added the loop. And this is exactly what we wanted to achieve. Have more vertices along the critical areas of the sculpting. I will show you this again in a moment, but let me introduce another very useful feature of Blender beforehand. We can temporarily hide selected vertices of an object, and this can help us here to get a clearer view of what happens on the model side. Deselect all vertices. Then select all vertices which you want to hide. You can do this at best in side view. Now press the H key. Immediately all selected vertices disappear, and now it is much simpler to work with the remaining faces. Please select again the loop division tool by pressing the Ctrl key, followed by the R key. Now it is much easier to find good loop locations. Click the left mouse button again, and shift the new loop to your desired location. Now select both loops. Hold down Alt, and right-click on the first loop. Then hold down Alt and Shift, and right-click on the second loop. Scale up both selected loops along X until they touch the adjacent sculpting. Then select the outer vertices of the loops. Move them along Z, and scale them along X until they fit nicely. You also can select the topmost vertices of the loops, enable proportional edit, and move them up a bit so that the bow fits even better. At the end, press the Alt key, followed by the H key, to unhide the hidden edges. You can add some more enhancements to the bow if you like, but that is up to your personal taste. For me, it is good enough as it is by now. Let us now bake the sculpt and see what happens. After you have baked the sculpty, there is a nice trick to immediately see the results. Go to Object Mode and select Top View. Then go to Image, Import as Sculpty. Move the new object a bit along X. This is almost what we can expect to see in Second Life later, but there is a small but important difference about how the objects interact with the environmental lighting system, but Blender has yet another option to help us here. Please locate the Link and Materials tab. There, select the Set Smooth button. Now your object sometimes turns partially black. This seems to be a Blender bug. If you see this to happen, then switch to Edit mode and immediately return to Object mode. The black parts should be gone. Now we see what we will get in Second Life, and that does not look too different from the original object. Please be aware that the Smooth button not only makes your sculpty look much better in the viewer. There is another very important issue here, which you must know about. The Set Solid and Set Smooth buttons define two different lighting models. And this setting directly influences the way how textures are baked. For the moment, let us say that the Set Smooth option will make the sculpty look very much similar to how it would be seen in Second Life. And let us keep with this mode for now. I will get back to this in the next tutorial. Let us now go back to Global View and adjust the size and rotation of the bow relative to the hat. I will go to Top View first, then also try to scale, rotate, and align the objects in other views. It may take some time until the objects are all in position. Okay, we have eventually created a satisfying shape for the hat. It is made out of 3 sculpties instead of only 1. And this is the moment where we start getting into real trouble. How can we transfer the 3 sculpties into Second Life? And how can we keep their relative positions, sizes, and rotations intact? Now there is another nice trick, which is again introduced by primstar. You can automate the setup of your sculpties in Second Life, but we need to do some preparations beforehand. First, go to Object Mode. Then select all your objects by holding down the Shift key and then right-click them one by one. Now go to Object, Parent, Make Parent. This makes the least selected object the parent of the others. If you select only this parent object, then all its children will follow any subsequent transformation. Now we will prepare the export of the entire object group. Select all objects by right-clicking on them and holding down the Shift key at the same time. Then go to Object, Transform Properties. A small window opens. There you see the current rotation and scaling values of your parent object. The rotation values should all be 0 here, and scaling should be set to 1. If these values are different, we might end up with unexpected rotations when later raising the objects in Second Life. You can clear the values without modifying the object itself as follows. Go to Object, Clear Apply, Apply Scale Rotation to Object Data. Now all object rotations have been set to 0, and scaling is set exactly to 1. And now the primstar baker can do all the rest for you. Still keep all objects selected. Then render, bake sculpt meshes. Keep with the default settings, and bake. It is important that the objects get baked at the same time, because now primstar will calculate a precise vertex alignment of the objects. Please note that this video was created with the optimized baker tool from the Jass Pro distribution. If you use primstar or the Jass public distribution, then the baking quality of the smaller parts might degrade a bit. After the baker has finished, you can control the results by examining the sculpt maps one by one. Just select each individual object, then go to Edit Mode and see that the sculpt maps have been created. Now go to your local disk and create a new directory. You can create it at any place in your system. Go back to Blender. Then navigate to File, Export, Second Life LSL. A file selector opens. Navigate to your just created empty directory. Then click on the Export LSL button. If you now check your just created directory, you will find all sculpt maps there, and besides them, there will be one single LSL script. It is time to enter Second Life and create a prim. Rename this prim to primstar. Take care to name it with a capital P, and take it to your inventory. Now create another prim, and place a copy of the primstar prim into it. Then import the sculpt maps, and put them into the inventory of the primstar object. Finally, create a new script in the object. Open the generated LSL script on your disk by using any text editor of your choice. Then cut and paste the script content into the just created script inside the prim. Save the script and close the Second Life editor. The prim generator will immediately ask for the permission to link objects. Answer: yes. Now click on the primstar object to start the generator, and watch how the object will be created from scratch. Finished. Your object has been raised, and all proportions are intact, and even the parent-child relations have been used to create the corresponding link set. We are now at the end of this tutorial. We have learned about the proportional edit tool. We have used local view and global view for easy editing. We have used the loop subdivide tool to add more vertices at critical areas. We know how we can temporarily hide vertices. We can examine the sculpt map on the fly. And we can get back smooth surfaces after re-importing the sculpt map to Blender. And we can transport a set of objects from Blender to Second Life. The next tutorial will entirely be dedicated to texturing the model. Until then, please take your time and improve your modeling skills by applying what you have learned in this tutorial. Have fun, and see you later!